Let's go through LeetCode 1392, longest happy prefix. For this question, it gives us a string S, and let's find the longest happy prefix of S. If it does not have such a prefix, return empty string. So, for example, LEVL. So, what is the happy prefix? Is that this one is also a suffix. For example, L, right? It is the suffix. So the longest is L. And also AB, right? So let's see. This AB, right? And it also that is a suffix AB, right? So the longest is AB. So of course we can do this question like a rolling hash, right? But since that the rolling hash, it is we cannot just compare the hash code, right? After we compare, we're using the sliding window to find whether the hash code equals equal or not, right? And then we extend from left to right and right to and to left. But even the hash code equals, we still need to compare the string because there is a hash collection. So for this question, we can use another algorithm called Z algorithm, right? So that is used to match the string, right? So if we have a string here, and what we create a Z array, it has same as string S, right? Same size, but the thing that it is an integer array, right? It represents from index I the max the length. We match the suffix of string, right? So for example, we have ABC here, and for this I, we have A, B, C. For example, this is ABE, right? So this part, this is 2, right? So this will be 2 because we match AB, right, from the beginning. So for this kind of Z box, if we do brute force, right? So so to match this one, match every substring, right? So it will still be not efficient, right? So because we should trying to have the length multiplied by match length by the whole string length, right? But since that we can do this in O(n) time to do the string mapping, is that for example, we already match this I, right? We know its Zi is to this kind of range, right? For example, to this range, and we can find a corresponding string of this suffix, right? So if we have here, for example, we match here, right? And match here. So when we iterate this I, right? So we'll say actually there is a corresponding I corresponding what's it J, right? Whatever to this. And this I have the same character with this J. And also any J to the end of this box and I to this end of this box, they have the same character, right? So we'll say if this ZJ is smaller equal to this kind of bond, right? We can say this kind of ZI is equal to ZJ, right? If this one exceeds this bound, right? After this, we did not calculate, then we just do brute force to compare one by one. So that is the algorithm of the Z algorithm. In this case, we save all of the Z array calculations in either this one, we do not extend the right, we just use O(n) time to calculate this Zi, right? Otherwise, if we extend this Zi, right, we right bound, we just extend it is like a slide window, right? And left bound goes to I, right bound to here, right? So every time we maintain a Z box window, and we'll say this will not go back this kind of window. So this is all in time complexity, right? So let's write code for this. If the logic here is that we have Z array here, and if we find, for example, an index I, we have Zi plus Zi equals to n, right? That means at the index I, we this kind of range, it's already be the same length of the n, right? That means, and also this matches this, right? So it means this part is a suffix and also prefix, right? So if we have I plus Zi equals to n, then we can just find the result, right? Actually, we don't need to compare the longest. Actually, the first one we find will be the longest, right? So we don't even need to, because the first one we find that is I plus Zi, it's already the one will be the longest, right? Because we're finding this kind of range. So let's begin to write code for this. Let's say char array equals as char array, and we'll have int n equals array dot length and left equal. This is the left bound of the Z box, right equals the right bound of the Z box, and then we're going to have Z equals new int n. Okay. So what we do is that for int I equals to 1, I smaller than n, I plus plus. So let's say Zi equals max dot max. It will not be at least greater than 0, right? And we cannot exceed the Z box right bound. So I have max dot min. Zi minus left, right? And this the will be right minus I plus 1. Okay. And we calculate while I plus the I smaller than n, and the I array the I, right? We compare the character array the I equals array I plus the I. This is the outer bound, right? We didn't calculate this part, so we need to have the proof false, right? So we'll have left equal to I, maintain the new window, right equals to I plus the I, and then we'll extend our the box right bound, right? So the first one we find that will be the longest, right? So we'll say if we have the I plus the I equals n, right? Then we just return s dot substring I. In the end, if we didn't find any, just return empty string, right? Okay. We can also compose this one to be Python code, right? So So let's change this one to be Python. So we are going to have n equals length s, right? So we'll have left and right, left, right equals to 0, 0, right? And we compose and z array equals this multiplied by n, right? So what we do is for I in range 1 to n. So as a z I equals max, it should be greater than 0, right? Because we are trying to find a max greater equal to 0, right? Max match from the prefix. So the main is that we cannot for those part we didn't match, right? We cannot exceed the right bound of the z box. So we'll have right minus I plus 1, right? So this is the zi, and we'll have while I plus zi smaller than n, and array, or not array, we should have s, right? S the I equals s dot I plus the I. We're going to have left, right equals I, and right equals I plus the I, right? And now we are going to extend our right, the zi, right? The zi, if we have a match, right? So the I plus equal to 1, right? So for the first one, we match, right? So we'll say any of the zx equal I plus the I or equal to n, right? We just return as I right, like this, right? And else we just should be here, right? Return this should be out of the for loop, right? Should be here. Return this. So this will be the Python code.